In 1946, Convair designed and built an airplane to meet airline and military requirements for a short and medium-range aircraft with a high payload at a minimum operating cost. This is the plane identified as the 240. It has an unequaled record for passenger safety, dependability, and economy of operation. One of the most unique features is the built-in stairway, designed as an integral part of the aircraft. This loading arrangement saves time for airline operators as well as passengers. Convair engineers developed this orange peel cowling to facilitate engine inspection at service points or terminals. The 240 was designed for fast, efficient servicing and maintenance. The engines, each packing 2,400 horsepower, give the airplane a 100% power reserve at all times, both in takeoff and in flight. The 240 is an all-metal low-wing monoplane with full cantilever wing and tail sections. It is equipped with a tricycle landing gear, which keeps the plane level on the ground and adds to the maneuverability while taxiing. Maximum gross weight for takeoff is 39,500 pounds, with a payload of 8,900 pounds. It takes off well under the 3,800-foot runway length required by the CAR. With an ample 3/4 of an hour fuel reserve, the 240 has a range of 830 miles and cruises at 300 miles per hour. Pressurized cabins maintain comfortable flight conditions regardless of altitude or rate of climb or descent of the airplane. The combination of the features shown on this airplane, its safety service record and minimum operational cost, make the 240 the outstanding short and medium haul airplane of its day. With the success of the 240 established, it was only natural for Convair to think in terms of building a newer and larger airplane. As a result, the 340 Convair liner was introduced in October 1951. This is basically a new airplane with a longer fuselage, a higher gross weight, more powerful engines, and many interior design improvements. The increased wing area, power, and fuel capacity enables airline companies to employ the 340 not only for short-range schedules, but also for medium-range hauls, which were previously serviced by 4-engine equipment. The design of the 340 allows maintenance and service crews to perform their jobs simultaneously. This means economical operation and time saved between hauls. This is the only commercial airliner designed with fuel tanks outside and away from the engine nacelles. This is another important safety feature. Hot food is easily loaded aboard for hungry passengers who will dine aloft. With servicing and maintenance quickly and accurately accomplished, the ship is ready to go on the next leg of its flight. For passenger convenience, the hydraulic loading door is on the forward left side as the most functional location. At airline training schools, pilots are taught to take off and fly the Convair liner on a single engine. After a short run, the plane takes off easily and clears the theoretical 50-foot obstacle at the required point with no difficulty. Other airline companies who use Convair liners know that this airplane has one of the highest safety records of any airplane flying today. It flies and climbs easily on one engine. Because of its performance and proven reliability, the Convair 340 airliner was purchased by 21 domestic and foreign airline companies, as well as 11 private industrial firms. The United States Air Force and the Navy ordered modified versions for military training and transport duty, bringing the total number of Convair airplanes in operation throughout the world to over 1,000. Larger tires carrying lower air pressure are an improvement, giving the airplane better handling characteristics on unimproved runways, on ice, or in snow. Heavier gear and softer tires reduce maintenance. Dual tires on the gear ensure against blowout failure. Beginning with this Convair 240, billions of passenger miles were flown by these airplanes, establishing an unequaled safety record, with more than 3 million hours of flight over almost 675 million miles of air travel. With the introduction of the 340, the reliability and safety records of the Convair liner continued to grow. From these aircraft came the Metropolitan 440, a new airplane with all the good qualities of its predecessors and a number of major improvements. The many features that have given Convair transports one of the best operating records of any commercial aircraft have been retained in the Metropolitan 440. The home of the 440 liner is in San Diego, California. All the vast resources of this plant are combined to make this twin-engine airliner one of the most efficient and practical of any airplane flying today. The construction is based on proven design with many new features. The huge wings were subjected to tests equivalent to 50 years of airline service. First, the interior of the passenger cabin is covered with sound damping foil. Next, thick acoustical blankets are added to reduce noise and vibration to a minimum. These airplanes are manufactured under the watchful eyes of skilled craftsmen on this modern production line. In this new versatile model, operators are offered their choice of the standard 44-passenger version or the newly designed expanded seating capacity model, which will accommodate 52 passengers and a crew of 4. The maximum usable fuel capacity is 10,380 pounds, and at average speeds of 289 miles per hour, the maximum range is about 1,210 miles, with a payload of 12,880 pounds. The 440s roll off the assembly line on schedule and with the colors and striping of the airline company that will use them. Now they will receive all ground tests and be made ready for first flight. After each airplane is checked out and flight tests are completed, airline representatives take over and fly the airplane to its home base. The cockpit is in modern styling with wide range of visibility and windows that will remain free of fog, frost, or ice. The instrument panels and all controls are positioned to facilitate every operation in flying the airplane. The placement is truly functional and acclaimed by pilots, both commercial and military, the world over. Electronic equipment in the 440 includes new and improved medium-high and very high-frequency radio communication sets, instrument landing equipment, and intercommunication facilities. Airline and military operators will notice a new look in the Metropolitan's nacelle. The exceptionally clean lines are further streamlined with an increased taper at the forward end and a rectangular exhaust port at the aft end, deflecting the noise down and away from the plane. The new silencer, developed after extensive engineering, reduces exhaust sound levels to a quiet whisper in the passenger cabin. The greatest aid in all-weather flying available for these airliners is the weather mapping radar installation. This enables pilots to avoid or minimize the discomfort and delay resulting from severe turbulence. The seeing nose makes tornadoes, storm centers, or other bad weather visible to the pilot as far as 150 miles ahead. By being able to route an airplane through an area of least turbulence, passengers are assured of a smooth flight without the disturbance of lightning strikes, hail, or buffeting. Thus, the airborne radar, coupled with all the other improvements in the 440, brings a new era to air travel, assuring passengers the utmost in comfort and safety. Because of the excellent performance of the Convair liner, United States military services selected it for a variety of tasks. This is the T-29A, or Flying Classroom. Training navigators is serious business. These are the men who will be responsible for guiding Air Force planes to destinations the world around. The versatility of the airplane permits training operations and training equipment installations comparable to tactical airplanes. The airplanes are designed for overall continuous and realistic training for flight and crew personnel. Comfort, adequate room for instruction and teaching, and learning aids have been considered in the development of these airplanes. The application to various training uses results in greater utilization and increased mobility of training command equipment. The working crew of the ship consists of the pilot, co-pilot, crew chief, and 14 students. All modern methods of dead reckoning, celestial navigation, radar navigation, and LORAN may be taught in this trainer. The equipment used is similar to the types installed in tactical bombers, transports, and troop carriers in current operation, including high-speed types. New or improved equipment may be installed in the trainer on the production line or at modification centers, as such equipment is developed and put into operational use. With today's airplanes flying faster, farther, and higher, the navigation of an aircraft is a vital operation. The T-29 flying classroom gives the student practical in-flight training. With the help of the latest electronic aids and other equipment used for in-flight computation, the final course and flight pattern is in the hands of the navigator. In addition to the various types of radar, navigational, and computing equipment, other T-29s are equipped with a ground position indicator and bomb scoring camera for training navigator bombardiers. The T-29 airplanes have the same configuration as the Convair liner and are pressurized for high-altitude operation. They have increased fuel capacity in the wings for sustained training missions at speeds comparable to some bombardment airplanes. This makes it possible to simulate in-training combat conditions. The training of bombardiers plays an important role in our national defense system and requires a continuous training program by the United States Air Force. After students have been through their schooling in the flying classroom, they are ready for assignment in airplanes like this B-36. Just prior to the actual drop, the bombardier takes over the control of the airplane for the bombing run. The many hours of patience, skill, and training all add up to one thing: a man trained to do a job and do it right. The use of the Convair liner provides a large reserve of aircraft which may be transferred to the logistic command for transport use in an emergency. Another version is the cargo or military transport designed for multiple use. A large hydraulic door, 6 by 8 feet, on this airplane permits easy loading of heavy equipment. Some transports are equipped with even larger doors, depending on the job to be done. The airplane has an exceedingly low replacement and repair rate and minimum spares requirements. It has a sturdy floor designed for a standard 20 by 20 inch cargo tie-down grid pattern. The entire fuselage is pressurized to 4 1600 pounds per square inch. Airplane accessibility permits rapid and easy servicing. Ground handling time and personnel are reduced by convenient loading and handling features. Another of the modified versions is the C-131B, a flying electronic test bed. 2 turbo generator pods slung from the underside of the plane are its distinguishing feature. One turbo generator develops alternating current and the other direct current with an output of 600 amps. The current is used to activate various pieces of electrical equipment to carry out practical experiments under flight conditions. Some foreign countries are also using military versions of the Convair liner. The ability of the airplane to take off with a short run and from small airfields with a rapid rate of climb is a big advantage. This is the R-4Y, produced for the United States Navy. It can readily be adapted to serve as a passenger or cargo transport and as a trainer or evacuation airplane. It is backed by the enviable safety, service, and operations records of Convair Liners and training airplanes. The Flying Samaritan, or hospital version, is the C-131A. Working together with helicopter rescue crews trained to carry out their jobs with speed and efficiency, it provides an important link in the rescue of sick or wounded personnel. Rapid evacuation pays off in lives saved. The C-131A has proved to be an ideal airplane for this work, especially where short takeoffs and landings are necessary to get in and out of tight places. The airplane has a pressurized cabin and carries a crew of 5: pilot, co-pilot, radio operator, and 2 medical attendants. This allows room for 12 litter and 18 ambulatory cases. Military planes, evolved from the basic design of an established transport like the Convair liner, have the advantage of confirmed aerodynamic design, established structural integrity, demonstrated equipment reliability, and proven service with maintenance simplicity. Convair liners are widely acclaimed by the men who fly them. Millions of passenger miles have been flown by domestic airline companies, as well as many international users. Around the clock, around the world, 24 hours a day, Convair liners are in the sky. They are flying all types of missions for the United States military services and allied air commands. They play an important role in the defense of our country, carrying supplies, performing training missions, and transporting military personnel to far-flung air bases. Smooth, safe, and dependable, whatever their task, wherever they fly.
Since 1946, this aircraft, a piston-powered Convair liner, has earned a history-making record for dependability. 1,081 have been produced, and 1,007 are still in use, with more than 12 million flight hours on their logs. Piston engines have served them well, but the advent of the turboprop brought new improvements to performance, reliability, economy, and speed. This is the Executive 600, a converted Convair 240 built for charter and business use. It blends aviation's most reliable airframe with dependable Rolls-Royce power. The Convair liner was designed for turbine power from the start. In 1964, the RDA-10 Dart was chosen as best engine for this airframe, and conversion for the 240, 340, and 440 fleets of several regional airlines soon began. More than 40 million hours of commercial service stand behind the Rolls-Royce Dart. Used by over 200 airlines throughout the world, it is 10 times more reliable than the piston engine it replaces. The RDA-10, most advanced of the Dart turboprops, develops 3,025 equivalent shaft horsepower. It has the highest initial time between overhauls ever granted by the FAA, 2,600 hours. The reliable, well-matched propeller is made by Doughty Rotol. Diameter is 13 feet. Other changes are an anti-skid braking system and a total service auxiliary power unit built by Garrett Air Research. The APU makes the aircraft self-sufficient with built-in ground cooling and starting power. External service units are not needed, allowing use of any airfield in the world. In flight, the APU has backup power for pressurization and electrical systems. The quiet, spacious cabin is air-conditioned on the ground as well as in the air. Pressurized to fly above rough weather, the 600 offers a smooth, fast flight and the comfort required for work or relaxation. Custom interiors can be designed for individual needs. There is ample room for a galley and lounge or for several compartments throughout. Whatever the arrangement, this is a flying executive suite that is built for busy people. For the pilot, there are shorter takeoff and landing capabilities, improved climb rates, higher cruising speeds, and greatly reduced maintenance for both the engines and the airframe. Water methanol injection boosts takeoff power and maintains that power constant up to 122 degrees Fahrenheit. The Executive 600 can fly more than 1,200 miles with full reserves at cruising speeds over 300 miles per hour. Now, with Rolls-Royce turboprop power, at least 15 years of high-performance life have been added to this aircraft. And it's available at a fraction of the cost of comparable new turbine equipment. Come fly with Convair and see what we mean.
The Convair Metropolitan. This is its story. And the story of a new era in commercial aviation. The Metropolitan. An airliner you can book your customers on with confidence and pride. Comfortable, dependable, modern. The Metropolitan was designed from the beginning with the convenience of your customers in mind. Your customers, each one just a bit different. Each one with his own individual requirements and his own important reasons for flying from here to there. You know them well. An elderly lady making her first flight. A businessman who will use the airplane to expand his business day. A father who wants this flight to make an unforgettable impression on his young son. Your customers. You can schedule them all on the Metropolitan with assurance that you're providing them with up-to-the-minute speed, comfort, dependability. In this new and improved version of the series of Convair Liners, which have already proven their worth in more than 800 million miles of service. This is the home of the Metropolitan, San Diego, California. Like the earlier 240 and 340 Convair Liners, the Metropolitan is manufactured by the San Diego division of Convair, one of the world's most experienced aircraft manufacturing companies. These buildings that you see here are the work areas for more than 20,000 Convair employees, designers, engineers, craftsmen. They've been drawn here from all over the United States and the world. Their variety of skills and experience played an important part in the evolution of the Metropolitan. This is a part of Convair's design and engineering building. Here in the minds and on the drawing boards of these specialists is where the evolution of the Metropolitan began. Its basis was a proven Convair design and an idea to make it even better. And slowly the sketches and figures became working blueprints and then parts. This is a full-scale Metropolitan wing. In this giant test device, it is being put through the equivalent of 50 years of airline service. That's more service than any airliner would ever see. The designers gave the Metropolitan powerful engines for superlative flight performance. Engines so powerful that special provisions were made to deflect their mighty roar from the passenger spaces. A completely new type of exhaust muffler was developed. Its distinctive rectangular shape actually aims engine noise back and away from the walls of the passenger compartment. And inside the walls of the plane, this sound detection test equipment was used to find where engine noise might penetrate. The meter indicated the areas where special sound suppression material should be placed. Foil sheeting, for instance. It's unbelievably light and as thin as paper, but when it's placed just so on the cabin wall and ceiling, it becomes a formidable barrier to sound. And in addition to the foil sheeting, more specially designed sound-absorbent material, light as a feather. It soaks up sound before it can reach passengers' ears. Afterward, the cabin lining is put in place and the interior tested again. The low meter reading found now visually shows why the Metropolitan is one of the quietest airplanes in airline service today. After the Metropolitan's many improvements had been engineered and thoroughly tested, the airplanes began to take shape in 100 different locations in the Convair plant at once. Each airplane's beginning is in precise hand operations and on individual workbenches of Convair craftsmen. It starts here, and over here, and at the same time here. And as the pace picks up, it grows and expands. The tempo of the operation is picked up by the bigger machines and power tools. The pieces increase in size and begin to take shape in ribs and sections and sub-assemblies. Routinely, carefully, skillfully, the airplane grows and grows and grows. This is the moment toward which thousands of hands have labored. Closer and closer and lock. This is the moment that the sections and the parts and the sub-assemblies become an airplane. A new Metropolitan. More than 900 transports have passed through this Convair production line and are now in service in all parts of the world. Here, the latest versions, the Metropolitans, are given the colors of the airlines which they will serve. Colors that will fly north, east, south, west, over all the continents of the world. At any hour of the day or night, in fact, somewhere at this very moment, there are scores of Convair transports plying the world's air lanes. And in the Metropolitan runs the bloodlines of other famous Convair aircraft. For these same long production lines have produced gigantic 10-engine airplanes, the famous Convair B-36 intercontinental bomber, powered by 4 jet engines and 6 pusher-type piston engines. The Convair Sea Dart, world's first water-based jet seaplane to break the sound barrier. And from Convair, too, came the R-3Y Tradewind, mammoth water-based transport. The new supersonic F-102 Delta Wing all-weather interceptor was built by Convair to guard America's skies, day or night, and in any kind of weather. And from the Convair production lines came the world's only airplane to ever take off and land vertically and fly horizontally. Here, then, the culmination. All the vast resources of design and manufacturing skill gained in the production of every type of aircraft are combined in the Convair Metropolitan, making this twin-engine airliner one of the most efficient and practical of any airplane flying today. The Metropolitan, based on a proven design and some new ideas. Manufactured under the watchful eyes of skilled craftsmen, assembled on a modern production line, and throughout every stage of production inspected again and again. For in the Metropolitan, nothing is left to chance. And now, the final tests, the test flight. These too are routine and thorough. These are the acceptance pilots assigned by the airline. They will test the Metropolitan routinely and carefully to make certain that the new airplane meets the performance requirements of the airline itself before it goes into service. The self-contained ramp fits snugly. The door closes, locks, and is secured. The Metropolitan is ready for flight. During this test flight, you will see a demonstration you may never see in actual airline operation. As a routine part of its series of flight checks, one of the Metropolitan's engines will be deliberately shut off by the pilot, and the airplane will be required to fly and maneuver and climb on one engine only. There are 2,400 horsepower in each of these giant engines. That means that each engine alone has more than enough power to fly the airplane, fully loaded with passengers and baggage, even on takeoff. The combined power of both engines is more than double the amount needed. This extra power is one of the big reasons that Convair airliners are a favorite of airline pilots all over the world. These airline acceptance pilots know, too, that behind each new Metropolitan lies years of experience and know-how in engineering, design, and production techniques. How simple. And yet what power. 4,800 horsepower at the control of one man's touch. Horsepower to pull the Metropolitan down the runway and lift it surely into the air. For the test flight, to show the real power of the Metropolitan's engines, the pilot deliberately shuts off one engine, and the airplane flies easily on a single engine, and climbs higher, and still higher. The tremendous power reserve in the Metropolitan assures smooth, comfortable flight. Its flying capability is outstanding on one or both engines. The acceptance pilots find that it maneuvers easily at high and low altitudes. And when the Metropolitan returns to Earth after its tests, proven and ready for airline service, its tricycle landing gear allows the airplane to settle gracefully and smoothly on the runway. Convair transports, with more ports of call than any other modern airliner, are familiar sights in every part of the world. They've lifted their passengers over the Earth's most noted landmarks and have carried them to and from the most faraway places. They are flown by more airlines than any other modern airliner and have covered hundreds of millions of airline miles. Now the Metropolitan adds new passenger comfort to Convair's outstanding record of dependability. The seats are wide and comfortable, and there are never more than 2 seats on each side of the aisle. Seats which may be adjusted with the touch of a finger for individual comfort. Above every seat is an individual control panel, placed there for passenger comfort and convenience. Fresh air may be personally regulated to the need of each passenger. And there's a separate reading light. Through the big picture window close to each seat, there's a constantly changing panorama. And if a passenger wishes to summon the stewardess for any reason, a button on the control panel will signal her, whether it's to answer some question about the flight or to provide a personal service. The passengers, young and old alike, agree that the most satisfying of all new innovations on the Metropolitan is its restful quietness. Quietness that was planned and built into the Metropolitan, so that relaxation and enjoyment come easily, even if you have yet to celebrate your first birthday, or may perhaps have celebrated quite a few. In the Metropolitan, even in the rear seats, it's possible to hear the ticking of a watch. The stewardess has direct control over the cabin temperature and light, so the cabin comfort is always just right. And while flying high above the clouds, the pressure within the cabin is regulated by a special pressurization system. Old-time airliners flew at low altitudes like this. Down here near the ground, the air pressure is quite comfortable for passengers. But the dense air sometimes makes for a bumpy and uncomfortable ride. Up here, at high altitudes where the Metropolitan flies, the air is thinner and smoother. But to keep passengers comfortable, to prevent ears from feeling plugged up, the Metropolitan's cabin is pressurized to provide comfortable, low-altitude pressure at the high altitudes where the Metropolitan likes to live. But one of the most important advances found in the Metropolitan is seldom seen by its passengers. It's located in the nose of the airliner, an electronic eye to pierce the darkness and choose its own path through any kind of weather. Airborne radar. Invisible electronic waves constantly probe the sky as far as 150 miles ahead of the moving airplane, searching out a clear flight path over or around clouds for the Metropolitan's pilot to follow by day or night. Radar, newest addition to many modern electronic aids, which make the Metropolitan a better airplane for a smoother, more comfortable journey.
May I have your attention? We are approaching our destination. Please fasten your seat belts.
In flight like a graceful bird, returning to Earth on a soft cushion of air. In the Metropolitan, the cabin floor is always level. For those passengers who will go on to another destination, there's less time to wait between flights. The Metropolitan's door opens hydraulically, and its own convenient built-in steps lower automatically into place. Another convenience which speeds up loading and unloading is this handy luggage rack in the forward compartment of the airplane. For these passengers, there will be no long waiting in line for luggage at airport check stands, and rapid clearance through customs is possible when it's necessary. The loading and unloading of bulky cargo is carried on through special large doors located in the rear and forward sections of the airplane, even while passengers are walking down the ramp. Having arrived at their destination with less effort than by any other method of transportation, Metropolitan passengers disembark ready and eager to fly again. Your customers, the most important people in the world. You've given them the best when you book them to their destination by...
Metropolitan? Metropolitan.
The Convair Metropolitan.
During the period of October 1957 through April 15, 1958, the Convair 880 commercial jet airliner began major component construction. Many subcontractors and vendors contributing parts and subassemblies from all over the country began making deliveries. The 880 program moved into full swing as the first production model of Convair's commercial jet airliner program was scheduled for test flights early in 1959. Significant in the period leading to this report was the construction of a complete metal mock-up in 880 tooling jigs, a metal mock-up that is being used to finalize all tubing, harness, and interior installations well ahead of production schedules. The swept-wing Convair 880 will be capable of operating from all airports throughout the world, now handling 4-engine piston aircraft. The ruggedly built Convair 880 was specifically designed for economical medium and short-range operation. But with the addition of the wing center section fuel system, it converts to a highly efficient long-range liner. In any range, the 880 is designed to provide the finest in passenger and operational services. 2 plug-type doors are located at each end of the fuselage for easier passenger handling. Opening or closing can be accomplished by the stewardess with a minimum effort. When the door is pulled to the fuselage, it slides downward and wedges into place and is safely secured in one simple motion. The interior features unique appointments in every detail of comfort and convenience. Standard seating arrangements will accommodate 88 passengers in luxury flights and 109 in the coach configuration. An airline crew can convert first class to coach in a few hours. The high safety qualities incorporated in the new dual window arrangement offer each passenger his own private viewing area. The 880 air conditioning system was developed and tested as a part of the 880 test program. 44 general outlets, along with 109 individual passenger outlets, supply a complete change of fresh temperature-controlled air every 2½ minutes in the passenger area and every minute in the smaller flight deck spaces. The 2 galleys have been compactly designed for efficient service. The spaciousness of the 880 cabin allows for more comfortable passenger seating arrangements than ever before possible. The advanced designs in 880 cockpit lighting eliminate distracting reflections and keep the instruments in the cockpit area glare-free. The glare shield keeps the windshield free from instrument panel reflections. White and red dimmable floodlights are used to eliminate the tunnel effect created by the shield. Similar floodlighting is available throughout the cockpit. The new use of printed circuitry makes each panel more compact and increases the effectiveness of the new improved dimmable edge lighting. The lighting designs incorporated in the flight engineer's panel simplify the operation of the 880's systems. In the newly constructed Convair Acoustics Laboratory, extensive sound testing has been conducted to determine the best material to be used in soundproofing the 880 cabin. The material to be tested is installed in the window separating a live room from the completely soundproofed room on the other side. In the adjoining soundproofed room, sound readings are taken. Over 100 materials have been tested in this way to determine the best possible soundproofing material to be used in subduing jet engine and aerodynamic sounds in the cabin area. On the outside of the metal fuselage section here in the large reverberation room, sound levels simulating the noise produced by the 880 engines have been established. Acoustic tests are first conducted on the bare metal fuselage section, and then different layers of soundproofing materials are added in a series of build-ups with tests in each stage. This is continued until a full-scale cabin mock-up has been completed and tested. Then furnishings are removed, testing is completed, and a final soundproof configuration established. In the General Electric plant in Evandale, Ohio, the CJ805 engines, 4 of which power the 880, are being manufactured. The military version of this engine is being used in the Convair-built B-58 Hustler, the world's fastest bomber. The Minnesota Mining and Manufacturing Company in St. Paul, Minnesota, contributed to the success of the Convair-developed manufacturing process called Scotch weld. This is a process that combines added structural strength with a greater fuel tank integrity, making possible the maintenance-free integral fuel tank. This design permits the use of the interspar box structure as a fuel container and gives maximum range with minimum maintenance. The Scotch weld tank has not developed a single case of fuel leakage in over 4 years of rugged military use in hundreds of F-102 and F-106 interceptors. The Scotch weld process begins in the cleaning baths built especially for the construction of the 880 at a cost of over $500,000. In the cleaning bath area, the parts to be Scotch welded are cleaned, chemically treated in special tanks, oven dried, Scotch weld primed, and force dried in the curing oven. In the assembly area, the Scotch weld adhesive film with its protective backing is applied over the drilled sections where metal is to be joined to metal and drilled to match the holes in the metal sections to be assembled. The protective backing is then pulled away, leaving the translucent Scotch weld film in place. And the fuel-tight rivets are driven. The completed wing assemblies are brought to the giant 880 oven built especially for final 880 wing curing. The $175,000 oven installation was thoroughly tested using a pair of R3Y wings similar in size to those of the jetliner. Once the oven curing is completed, the wings are ready for mating. At Convair's structural test jig, the Scotch weld system is once again tested in an 880 wing section. The purpose is to demonstrate the fuel-tight integrity of the Scotch weld integral wing fuel tank by load cycling under pressure and adverse temperature conditions. Testing is done at temperatures ranging from 65 degrees Fahrenheit below zero to 160 degrees Fahrenheit above. Internal pressures range from 3 to 10 pounds per square inch. External load cycling pressures exceed 13,000 pounds. Medium-range transport aircraft are subjected to more strenuous punishment than long-range transports, and these highly successful tests have subjected the 880 wing to stresses far in excess of those that will be encountered in normal operation. No fuel leaks have occurred in any test conducted. The last of the famous Convair 440 liners, in service throughout the world, reached the end of their assembly line as the earlier phases of the 880 tooling program began. With the completion of the highly successful Convair liner program, over 1 million square feet of floor space became available for the production of 880s. The near-sonic speeds of the 880 require a higher degree of precision construction than ever necessary in the slower commercial airliners of the piston era. Pioneered by Convair in supersonic F-102 and F-106 interceptor construction, optically aligned tooling jigs are used to build the 880. A revolutionary new tooling method that makes possible the highest degree of accuracy in aircraft precision construction to date. Optical tooling means simply that large fixtures are constructed along lines and angles that are established optically. From this basic principle, a jig big enough to assemble a complete 880 wing can be aligned for construction. An alignment telescope is precision mounted on one end of the jig. An illuminated target is precision mounted on the opposite end of the jig. Facility gauges or locators are added, in which bullseye targets can be inserted and positioned in strategic locations along the frame to be aligned optically so that a basic precision line of sight is established on which the wing buck will be built. This fundamental procedure is continued through all necessary angles until the tooling jig is completely aligned, and on which an 880 wing can be assembled with precision accuracy. Periodic checks are made to ensure that the jig remains true, and construction becomes a matter of basically clamping parts to the pattern and riveting them until the wing is finished. Approximately 30,000 structural parts needed for a single 880 are meeting regular production schedules. Cover plates, forgings, channels, sump castings, landing gear mechanisms, ducts, fuselage skins. The world's largest radial draw former, built to Convair specifications at a cost of $800,000, is one of the many special installations added to the 880 production line. A tremendous pressure of 75 tons is applied by the draw forming machine to raw stock, and in a single movement, one of the huge fuselage belt frame sections is formed and ready for assembly. In the spar mill area, 3 different size spar mills are being used in the manufacture of 880 wing spars. A 30-foot mill, a 66-foot mill, and the 108-foot Onsrud, installed for milling the larger 880 wing spars. The spar rails are fitted to optically aligned jigs on the spar tables, and webs and stiffeners are added, drilled on the new automatic gantry-mounted drill, and riveted. The individual spar sections are then moved to the optically aligned vertical tooling jigs, where the 2 sections making up a completed spar are joined and the pylon fittings added. When the spar has been completed in the vertical jigs, it is ready for the major wing assembly. In the wing skin and stringer panel optically aligned jigs, the wing panel sections are being constructed. The stringers are fitted and clamped to the tooling pattern. The wing skins are then lowered to the tooling jig and fitted to the stringers, and riveted, and the wing panel is completed. In production areas throughout Convair San Diego Plant 1, the major components of the 880 are now meeting production schedules. From the earliest test stages through more advanced testing, the 880 has moved steadily toward full-scale production. Huge equipment installations have been designed and installed. The thousands of small parts used in the liner are meeting weekly production schedules. The first flying version of the 880 is now under construction and will be the first of a full-scale production program aimed at producing 6 Convair jetliners each month. The 880 has grown from an idea into production and is moving steadily toward the first test flights scheduled for early in 1959. Here now is Mr. Sandy Cogan, Convair Vice President and San Diego Division Manager.
What you have just seen represents the progress we here at Convair have made in developing a commercial transport that will answer the needs of airlines for many years to come. In the past, we have shown you the extensive test and development programs that have been in progress for over a year. Now you have seen the immense production program currently producing the 880 jet airliner. From this beginning, 880 manufacture is moving toward a full-scale program capable of supplying airlines all over the world with Convair jet airliners beginning early in 1960. Able to land in over 335 cities throughout the United States, Canada, and Hawaii, the 880 is the only airplane initially designed for the rugged demands of medium-range service. Typical of some of the routes the 880 can service: Chicago to Kansas City, 405 miles. Kansas City to Los Angeles, 1,368 miles. Los Angeles to Seattle, 964 miles. And of course, cross-country, San Francisco to New York, nonstop, a distance of 2,580 miles. Although designed for medium-range service, the versatile 880 will economically fly routes as short as 250 miles, or with the addition of the wing's center section fuel system, non-stop routes as long as 3,250 miles. This means that the 880, purchased for medium-range work, can be used by an airline to supplement larger jets on long-range flights, and it will do so at less than 2/3 the cost involved in operating the larger ships. The extra speed, combined with the fact that it is the only jet transport initially designed to operate economically with a deluxe 4-abreast seating arrangement, virtually assures that passengers will prefer to fly in the 880. The 880 will fly 615 miles per hour, making it the world's fastest airliner, faster than any competing jet transport by a substantial margin. This extra speed, combined with a turnaround period of only 25 minutes, gives the 880 an excellent work capacity. For instance, the 880 cuts almost 40% off the time required for current aircraft to make the trip from Chicago to Los Angeles. The trip now requires 5 hours and 24 minutes. The 880 will fly it in 3 hours and 25 minutes. This speed advantage and the rugged construction of the 880 means longer first-line life than has ever been realized in the past with piston engine aircraft. It will be first-line equipment for at least 12 to 15 years, and in some cases, as much as 20 years service will be realized on the routes for which it was initially purchased. On a 1,000-mile trip, the 880 need carry only 34 passengers to cover the total cost of operation. Conservatively then, a 60% annual load factor on a 1,000-mile run, such as New York to Miami, would earn an airline $2,125,000 a year, based on a 10-year depreciation. Forecasts show that airline traffic in the U.S. will more than double by 1965. Traffic that will require jets like the 880. Convair is proud to announce that the tempo of production is increasing daily. The first 880 will fly early in 1959, and we at Convair are confident that the 880 will be the finest and safest in jet air travel.
This is the Convair 880 commercial jet airliner. More than 4 years have been devoted to developing and proving the 880 to make it the finest and safest modern jet transport possible. From 880 assembly lines now producing on a regular production schedule, 4 880 aircraft were specifically assigned to the test programs. 3 of these aircraft have been flying on regular test schedules. The other was assigned to ground tests here in the structural test facility. Its task was to demonstrate 880 ability to withstand the maximum flight loads it was designed to take. Rigged in these elaborate whiffletree arrangements, the aircraft was deliberately twisted and bent in a series of instrumented tests. Tests that were designed specifically to explore maximum designed loads in a program that simulated all operational extremes of flight through all types of weather. During these investigations, hard landings were simulated up to design limit loads. Engine pods and pylons were tested to extremes to simulate side gust loading, such as would be encountered in rough, stormy air. The fuselage was pressurized and deliberately deflected with massive loads to prove its ability to withstand forces that might be encountered during a pullout, such as would result from an abnormally steep dive. Typical of the tests conducted on the aircraft were those accomplished in the vertical tail areas. Diametrically opposed loads were used in a torsion test that applied maximum loads to the vertical fin in one constant direction, while at the same time, opposite loads were applied to the rudder. A test that explored strains that could be encountered during an engine-out condition. In tail fin bending tests, loads of up to 32,000 pounds were used to bend the vertical fin 15 inches off-center. A test designed to simulate maximum side gust loading conditions. Critical wing deflection tests were undertaken to simulate maximum wing loading, like the strains that could be encountered in a severe stall or pull-out maneuver. During this test, the wings were deflected as much as 6 feet, with loads ranging as high as 160,000 pounds. Downward deflection of the nose area was in excess of 1 inch, with over 43,000 pounds of load in this area. Aft section loading was 100,000 pounds, with a total downward deflection on the section of only 8 inches. The aircraft returned to normal following these maximum loads with no problems encountered. In each phase of the test program, the airplane was fully instrumented and results recorded for complete evaluation. The aircraft was engineered to exceed these test limits by 1.5 times the maximum design loads applied without sustaining any major structural failure. On assembly lines now producing 880s for delivery to airlines, an 880 was constructed to undergo an exhaustive fatigue cycling demonstration. It was installed in a special tank measuring 110 feet long by 20 feet wide. When filled to capacity for the test, the tank contains nearly 400,000 gallons of fresh water. In the investigation currently in progress and scheduled to cover more than a year, the fuselage will be continuously cycled underwater in a test that will simulate more than 20 years of first-line service operation. A system of hydraulic actuators are used to apply the strains that would be encountered during actual ground or in-flight operation of the aircraft. The fuselage was constructed complete with stub wings. Addition of the wings permitted full-scale examination of the fuselage, including strains produced in the wing root area. This is the first time that the combined fuselage and wing section of a commercial jet aircraft have been fatigue tested this extensively in the United States. The test is being run on a weekly basis. Approximately 5,000 cycles are completed each week. The tank is then drained for a thorough inspection and refilled for continuation of testing. Control of the test and recording of data is done in a structure adjacent to the tank. Here, through an electronic time-controlled cycle program, the fuselage is automatically put through a complete landing, taxi, and flight cycle each minute. Each 1-minute cycle simulates 1 hour of actual flight time. During the cycle, the fuselage is pressurized from 0 to 8.6 pounds per square inch internal pressure, well in excess of maximum in-flight operation pressures, and then back to 0 again. Stresses applied to the aircraft during various stages of cycling range from 1.22 to 1.85 times the pull of gravity. Daily inspections are made by specially trained crews of divers to ensure that no trouble could go undetected at any time. As a result of these tests, airlines purchasing the 880 will be furnished with inspection manuals that will contain information on the tests and serve as a guide for routine inspections for the life of the aircraft, in addition to ensuring that the aircraft will maintain its airworthiness serviceability through a full first-line lifespan of 20 years. More than 400 in-flight test hours have been completed by the 3 test 880 jet airliners involved in the program. The availability of these aircraft to meet flight schedules has been the best of any aircraft ever tested at Convair. 3 and 4 engine minimum takeoff performance and maximum effort landing investigations were conducted at the Air Force Flight Test Center at Edwards Air Force Base, California. These tests were conducted to determine takeoff capabilities at various weights and required runway lengths using both 3 and 4 engines. Minimum landing distances and rejected takeoff distances were also established. Over 200 stalls were completed in the program to determine slow-speed flying characteristics in varied configurations. Fuel jettison on the 880 is accomplished through 4 fuel nozzles located in pairs near the aft tip edge of each wing. The nozzles eliminate the customary extendable dump chute. They are permanently fixed with no moving parts and no maintenance requirements. The pattern is such that fuel can be jettisoned at all speeds without impinging any of the aircraft surfaces. Flow rates for the system were established as being well above those required. It is able to dump 51,700 pounds in a period of 20 minutes, 65% faster than minimum requirements. Each of the 3 test aircraft is specifically instrumented for the particular group of tests being conducted during any given flight. Basic data receiving equipment includes an airborne tape recorder for permanent record and a direct reading oscillograph. 2 photo panels containing all instruments pertinent to the test. A temperature recorder automatically keeps a record of temperatures in all areas of the ship throughout the entire flight. During flutter tests, telemetering is used. In these investigations, the pilot contacts the facility and initiates the test event by means of a countdown. All flutter flight activities are monitored here in the telemetering facility. Once a test has been initiated by the pilot, data is transmitted as it is produced on the aircraft to recorders capable of handling 20 separate data functions at one time. In addition to the permanent record, discriminators break the incoming RF frequencies into voltages that are graphically interpreted in visual form for an immediate quick look evaluation. With the test satisfactorily completed and tabulated, clearance is then given by the facility to the aircraft to continue to the next checkpoint. both here in San Diego and at the Edwards Flight Test Facility, extensive testing was done on the thrust reverser system developed jointly by Convair and General Electric for the CJ805-3 engines that power the 880. Over 100 taxi runs were made to establish cascade settings that would achieve optimum efficiency. During all test flights completed by the 3 880 test aircraft to date, no engine changes have been made as a result of engine failure. The 880 is now leaving production lines on regular schedules, ready for delivery. During the test program, it has proven its ability to land and take off well within performance predicted limits, and in level flights has more than met speed performance guarantees by demonstrating its ability to fly at its optimum estimated speed of 615 miles per hour. All Convair testing has been concluded, and emphasis is now shifting to final Federal Aviation Administration certification testing. Certification will be completed by spring 1960, with first deliveries beginning in November of 1959 to Transworld and Delta Airlines. This then is the Convair 880, the world's fastest jet airliner. Structurally and performance proven, luxuriously appointed, versatile, the most advanced jet airliner available to the flying public today.
A champion is always news. But being a champion means more than headlines in the papers. It means that in terms of performance and accomplishment, the efforts of one are proven superior to the efforts of all others combined. And if by chance we could personally meet those who know the champions best, we'd probably want to ask the same basic question that most people would. How did they achieve their eminent position and success? Our story is the answer to that question. There's been a lot of talk about speed, but there can only be one fastest jetliner, only one speed champion. On its delivery flight, Delta's first Convair 880 became that champion, setting an ocean-to-ocean transcontinental record with an average speed of 665 miles per hour. But speed is only one facet of performance, and there are many ways to look at a champion in order to find out the many interesting things you want to know. Take an airline captain with 20 years' experience. His introduction is filled with technical details. How does she handle? How does she perform? That's what he wants to know. And the answer is as smooth as silk. On the ground, aircraft engineers and maintenance crews look at it from a different point of view. The trim, sleek lines, the sweep back of the sturdy wings are to them symbols of integrity, an integrity of concept, design, and structure. Looking more closely at the structure is, in a way, a preview of the 880's whisper-quiet cabin. Part of that quiet you can credit to the use of a thicker outer skin in keeping with the principle of integrity of design. Silent flight is engineered into an airplane's cabin. It can be accomplished by using a heavy aluminum foil sandwich with a special plastic backing. Then, over it, apply thick blankets of fiberglass insulation. Now add triple panel windows with air spaces in between. And then round out the quiet engineering with a floating inner shell of panels that help exclude or help absorb nearly every bit of sound. And also credit a big assist from the powerful General Electric pure jet engines. The smooth turning turbines and compressors mean dependable vibration-free performance. And the integral sound suppressor, a daisy petal-shaped exhaust outlet, provides a tremendous reduction in sound level. But technical details are only a preliminary briefing to a more personal introduction to the jetliners with the fastest scheduled time of any jetliner, the one they call the quietest distance between any two cities. And ask Jim Thompson. A call between two cities can be interesting too.
Hi, honey.
Hi.
Everything's done. I finished the meeting sooner than I expected, and I'm on a Delta 880 flight, so we'll have dinner together.
Oh, I have to get my hair fixed before I pick you up.
You won't have time, dear. We're leaving in a few minutes, and the way traffic is, you'll have to start within half an hour.
Jim Thompson is explaining to his wife a present-day fact of life. With jet speed being what it is, most of us have to figure that it can take longer to go to and from the airport than it takes to travel 1,000 miles in the roomy cabin of your 880 jetliner. Forward of the main cabin is the club compartment. And as you relax back in your seat, you are ready for the wonder of your introduction aboard the fastest jetliner in the world. In that intimate but spacious club compartment, there is no speed sensation. The only sound you hear is from the air that is slipping by outside. The hum of friendly conversation is much the same as in your living room. And just the way it is at home. Don't let a member of the family give you too much good advice.
As a stewardess, I've served on a lot of different kinds of airplanes. But no plane has ever had the same appeal to passengers that these new 880s seem to have. Maybe it's because racks overhead are easier to reach. And maybe it's the special air conditioning that gives a uniform and pleasant climate anywhere they're sitting. Maybe it's because there's a certain home-like feeling in the cabin. But I guess it doesn't matter what the reasons are. The main thing is that all my passengers enjoy every minute they're on board. If there's work to do or just relaxing, time seems to float right by. So quickly, quietly, and so very pleasantly that anyone can rest without ever getting restless, even the very youngest generation. When we're on between-meal flights, many of our guests get added pleasure from a tasty snack. And, if they like, the cocktail of their choice, to sort of tide them over till they reach their destination. Of course, dinner time for some can be absolutely any time, and we tide those folks over too. Everything does seem easier when you can fly 1,000 miles in less than 100 minutes. Pure white, pure jet, pure luxury. And Mr. Thompson can't help wondering if his wife has run into some of the usual heavy highway traffic that might hold her back from arriving at the airport in time to meet his 880. that's already coming into land. From way up north to way down south, people at the airports can recognize our 880s by their streamlined look and that pure porcelain white finish. But the passengers who fly on them can tell by 101 little things that one way or another, the speed and comfort of the fastest planes add much more than just a time advantage to their vacation or their business travel. And as a stewardess, you get to understand why parents find it easier to fly, or how much passengers appreciate thoughtful service and consideration on the ground as well as in the air. And you know why Mr. Thompson asked his wife to start out early when meeting his 880. Every year, I travel almost 500,000 miles between a score of different cities, and one good thing is always true. Whether your passengers are 100,000 milers or if they're on their very first 880 flight, they all seem to feel instinctively that they're flying with a champion, and it's a feeling that they like.
At day's end, twilight sunshine seems to last a little longer in the sky. And cabin lighting, indirect, flows softly from behind the sculptured panels overhead. It's a pleasant time to travel because you know that in more than just a general way of speaking, you've almost reached your destination when your 880 leaves the ground. It's only natural for a youngster to take a lot of things for granted that those who've been around a little longer can appreciate more fully. For a man whose type of business can keep him on the go, speed has an extra special meaning that only those who travel often can truly understand. Evening time is mealtime, too. And Royal Jet Service hospitality adds a certain flair to dining that makes you feel you're glad your appetite is healthy. And anyway, tomorrow is a better day on which to start the diet you made yourself a promise you would surely start today. There are 3 stewardesses aboard and twin buffets installed at each end of the cabin to help make the service even better. But here in the quiet of the cabin, there is no need for haste, although the world below is speeding by more than 10 miles in every minute. And there is one more thing to know about this champion of the airways, perhaps the one thing with the greatest meaning and most personal appeal. Because of its ability to fly in and out of intermediate-sized airports, the 880 will bring the benefits of jet travel to people sooner than they could be served by other jetliners. And therefore, to many people, in many places, the 880 is opening the door to the wonders of jet flight that have made travel by air today the most satisfying way of travel that we have ever known.